My name is Bryn Rhodes. This is CQL for authors. We're going to be focused on using CQL to build content like decision support rules, quality measures, and I'm currently the Director of Standard Strategy for Smile Digital Health. And in HL7, I'm on the Clinical Decision Support Work Group, FHIR Management Group, and the Terminology Services Management Group. So learning objectives, we want to understand using CQL with FHIR Implementation Guide. This is a new implementation guide that we've just recently published, STU1, balloted an STU2 in January, and we're about to publish that STU2. Author CQL that can be shared across use cases, so all the way from single patient decision support all the way up to population health and analytics use cases. And then use VS Code to author and test CQL artifacts. We're going to focus on that in the Let's Build session following. And then know where best practices are documented and how to contribute to those best practices and common libraries. So let's start with what is clinical quality language. I'm assuming some familiarity with that. I see some familiar faces. I'm going to go through, I have a lot of slides here, so I'm going to go through some of them pretty quickly. But to level set, it's a domain-specific query language designed to represent and share clinical logic. It's clinically focused, so it's focusing on those things on those logic problems that arise commonly in clinical logic, meaning that it has first-class elements for things like terminology and timing support. It's platform and technology independent. It doesn't care what your platform is or where it's running. It's intentionally independent of those concerns. It's computationally complete. It has a full suite of operations for string quantity manipulation and relational and list manipulation. And it's pure functional. It does not allow updating. It only computes. So then let's say why clinical quality language. I need a formalism that can let me express and share clinical logic all the way from a single patient decision support all the way up through population health across the entire spectrum. When we built CQL, it was focused on harmonizing between those two domains. We had, in the decision support domain, we had VMR, and in the population health domain, we had QDM and HQMF. And you couldn't really bring those together. They were completely separate technology stacks, so you couldn't share content between them. But they really are two different sides of the same coin. When we talk about what it means to be a diabetic in a decision support case, we should be able to use that same logic in a population health case. And so we focused on those two extremes. If I come at expressing clinical logic from the population health case, then I'm baking in context that applies to the measurement use case, like measurement period. Or if I come at it from the decision support case, then I'm baking in contextualization to the current time frame. So I need a way to express that logic and to be able to share it across the entire spectrum. So by hitting both those ends, we actually also hit all of the use cases in between. Case reporting, case management, clinical trials, care gaps, quality reporting, medical policies. Because CQL is just an expression language, and I can express things in terms of a patient or a location or a provider, I can share that logic at those different areas and through those different levels. And again, the execution framework isn't part of CQL. So we're focusing on expressing the logic in a way that lets us share it. So the CQL specification is there. We actually just recently published 153, an errata to the publication. It's been published normative since May of 2020. We will be balloting it vNext in September. There's a whole bunch of things on the list to get in, but this talk isn't about that. Next is the Using CQL with FHIR IG. This is a more recent publication, but this is taking all of the guidance from all of the implementation guides that have talked about CQL and pulling out only those things that talk about the intersection of CQL and FHIR and putting them into a single implementation guide. In particular, this includes things like the FHIR model info, that when you say using FHIR, that's now published in the Using CQL IG. FHIR Common, a library of common functions that are used throughout, those are now published in Using CQL IG, and we'll get into that a bit more. And one more goodie, there is a CQL cheat sheet available at that link. It is in the CQL formatting and usage wiki, if you're familiar with where that is. But it's just a cheat sheet that we've put together and made available. All right, so let's start with decision support. The running example here is a U.S. Preventive Services Task Force recommendation for screening for colorectal cancer. You should do that starting at age 50, continuing until age 75. It's a grade A recommendation per the U.S. Preventive Services Task Force 2016. We'll note that this recommendation was updated in May of 2021. The updates have purposely not been considered here yet, so it's an exercise for the reader to update that as part of the exercise. Appropriate screenings are defined by any one of the following: colonoscopy every 10, flexible sigmoidoscopy, and so on. So there's a series of elements that would meet appropriate screening according to this recommendation. So we'll start by pointing out the colorectal cancer content. So this is a CQ Framework content implementation guide. It's on cqframework.org. It's at cqf.ccc. You can see the link there. That's to the repository. If you clone that repository and you have a VS Code with the CQL plugin, then you'll be able to run all these examples and see what we're doing through all of this. The key here is that this is a FHIR implementation guide whose main content is a decision support rule and a quality measure and the associated libraries to run those rules and measures. So starting with the decision support, reasoning as a service, if you have a clinical reasoning implementation that exposes that capability via a CDS Hooks API, then when your EHR calls the CDS Hooks request, passes the data according to the data requirements surfaced by the plan definition, the prefetch in CDS Hooks, that information is passed in the CQL libraries, run through the apply operation, and you get a care plan with request group as the response, and that's converted into a CDS Hooks response and sent back to the EHR. So this is the actual request that's happening from the patient perspective in the clinician workflow, and we're actually using underneath a plan definition apply to run the decision support. That plan definition represents an event condition action rule. So when some event occurs, in this case, it's the patient view. This is an example of an ANC contact. You can put, it doesn't have to be CDS Hooks. You can put any kind of events in there. Your client needs to understand how to plug that in. So when some event occurs, if some condition is true, then perform some action. And so the plan definition points to a library to evaluate that condition. That's where the CQL lives. And then the plan definition points to an activity definition to surface whatever you're doing. If it's order a medication, if it's apply a procedure, whatever it is. So with the case of the colorectal cancer CDS rule, this is the narrative view of the published IG for that plan definition. Colorectal cancer screening, U.S. Preventive Services Task Force recommends screening, and it references that library. The if applicability is recommendation applicable. So this is saying there's an expression in this library called is recommendation applicable that I'm going to run on this patient to evaluate whether or not to show this screening. So this is that library, colorectal cancer screening CDS. It says we're using FHIR version 401. We're including from that using CQL IG, we're including FHIR helpers and FHIR common. We're including a colorectal cancer elements library. We'll dig into that a little bit. And then we're defining the is recommendation applicable. So this is the library that's actually being called from that plan definition. So the first thing we'll look at is the model. This is saying using FHIR version 401. And so how does it know what that model is, where it lives, how to pick it up? Because CQL is a model independent language. You just tell it what the models look like. So for FHIR, we actually specify that model info. Each data model defines the types available in the model and the primary code path for each retrievable type. And it also says what a patient looks like. So what's your context? This using CQL with FHIR STU2, that's a little busy. That looked better last night. There's from the authoring drop down here, there's 3 pages. There's the FHIR model info, the FHIR helpers, and the FHIR common. And so this is like a documentation index for those 3 libraries. In the FHIR model info, we have a list of all of the resource types that you can access in that model info, and you can see what the associated primary code path is. So for adverse event, for example, if I just pass a terminology in the retrieve, it's going to use event as the primary code path if I don't specify one. Then there's the FHIR helpers library, which again just provides conversion functions between CQL primitives and FHIR primitives, so a CQL quantity to a FHIR quantity, things like that. And then FHIR common is a bunch of, and we'll dig into that more in the Let's Build, but it's all of the things that we've built up through building these artifacts across the different implementation guides and pulled back and refactored to things that apply across any use case that works with FHIR, no matter the implementation guide or the domain. So derived model info, for use with FHIR, we actually extract from the resource profile definitions the model info. We actually generate that. So there's more about this in CQL with implementation guides and versions. We'll talk about that on Friday, especially the bit about versioning so that we can bring in multiple versions of the same implementation guide and talk about data from different versions of US Core, for example. So next up is the included libraries. You'll see this namespace here. This might be new to some folks. Usually we don't have that and everything's just in the same directory. We're now able to take advantage of libraries published in implementation guides. And so this namespace is actually the package ID of the IG. I don't have a pointer, but the namespace here, hl7.fhir.uv.cql. So that's the package ID. Oh, we do have a pointer. Maybe. All right. That is the package ID. And so for any implementation guide that you publish to the FHIR registry feed, if it has libraries in it, those libraries, those CQL libraries will be available via that shortcut, right? Your namespace is your package ID. Perfect. We'll probably only use this for this. But that namespace is your package ID, and then you can access the name of the library. And so this works by that name is the same as the tail of the canonical URL for the library, and then the canonical for the package is mapped to the namespace. So in the ELM, if you actually look at the ELM, we use the canonical to map to that package ID, if that makes sense. The version has to match, yes. So that 401, and you'll notice the FHIR helpers, we kept the version 401, That is because it would be just way too confusing to have the FHIR model have a different version, right? Because this FHIR model is now actually published in this HL7 FHIR UV CQL, using FHIR with CQL. So it has a different version than all of the rest of that implementation guide. The rest of that implementation guide is version 2.0.0. But it would be way too confusing to say using FHIR version 2.0.0, because then it would look like we were using DSU2, and we don't want to do that. And FHIR helpers, did I lose my, okay, FHIR helpers is cohesively tied to that FHIR version. Everything in FHIR helpers talks about what's in FHIR, and so we kept that version at 401 as well. But the FHIR common versions with the using CQL, because that FHIR common is just a bunch of libraries that are libraries, functions, declarations that are associated with using FHIR. All right, and then include colorectal cancer elements. There's no namespace there because this library is part of an IG, and so when it builds and publishes, it will be given the namespace of the IG that it's in. So this one is in CQF CCC, so it gets FHIR.org /guides/CQF, right? As you saw in the run up there. All right, so that's how we include libraries. Then this is recommendation available actually calls into that elements library. But it does so from the CDS perspective, saying this is how I use these elements when I'm talking about decision support use case. The elements themselves, actually one more thing we want to talk about here in the recommendation applicable, this context. We say context patient. That means that, show of hands, who knows what context patient means, and do I need to get into it? Right, it means that, so it's sort of like compartment in FHIR. FHIR has a patient compartment, and if you dig into the patient compartment, then things are from the perspective of that patient. Context patient in CQL means that all the subsequent expressions will be evaluated from the perspective of a patient. You don't know what patient when you're authoring, but it's from the perspective of a patient. So if I say, give me all the observations in a patient context, it will be, I'll get the observations for that patient. Brian.
So how does it indicate that it's a single patient versus a population of patients?
So the key is that you can run it in both ways, and it's up to the environment when you run it to determine that. So if you're running it at the population level, then the environment needs to provide that. Usually that's done by parallelizing and just running patient at a time. But you can also, as part of the transformation when you run it, expand those expressions into like observation across patient.
So the expectation is it's being run on the context of a patient, the fact that you run it across a population is relevant. Is that what you mean?
Yes.
Yeah.
Yep. From the authoring perspective, you can consider this from the perspective of a single patient.
Yeah.
What's another possible value of context? Why does it care that it's a patient?
Yeah, so your model can define any number of patients. In FHIR, we use the patient compartment, your model can define any number of contexts. And in FHIR, we use the compartment definition to say what the available contexts are. So location, practitioner, organization, and patient. And those are roughly correspond to the FHIR compartments. So if you're running a structure measure, right, that says how many beds do I have at this facility, that would be context location. And then your device expressions would be from the perspective of the location. And it works the same way, you're just running it at the location instead of the patient. Patient is by far the most common that we see, like 99.99% of all content. But if you look at some of the saner and safer stuff, they have outcomes and structures measures that are at the location level, where they're focusing on a facility and they're not even talking about patients in some of them. Okay, let's see, 23 of 67. So I'm going to start. I'm going to start breezing through. All right, so this is then the cancer elements library. So this has appropriate colorectal cancer screening. This is basically the characterization of that recommendation. There's a fecal occult blood test result within a year, or a fecal immunochemical test, DNA result within 3 years, colonography within 5 years, and so on. So that fecal occult blood test result within a year is that there's a fecal occult blood test result where it's issued 1 year or less on or before as of. And that as of is a parameter to this library. So if I'm running it in decision support, I give as of today, and that gives me the data within the encounter that I'm looking at. But if I'm running this in a quality measure context, then that is a measurement period, and the as of is the end of the measurement period. That fecal occult blood test result, the key there is that observation in concepts.fecal occult blood test. That is a retrieve, and that's the thing that is impacted by when you say context patient. That's the thing that says these observations are not only have a code in this concepts fecal occult blood test value set, but also are for the patient in context. All right, so then just a quick aside on terminology. One of the patterns that we've found is really helpful is to isolate all of your concepts into a concepts library. So you'll see this throughout a lot of the content that we have. We put the concepts into their own library. This gives us a way to kind of see all of the library, all the concepts at the same time. We also can pretty easily map them if we need to for a local setting, for example. We can pretty easily switch out all of those value sets for value sets in your local environment. CQL supports code systems, value sets, codes, and concepts. It does not define them. You can't define a value set in CQL. You can only point to an external definition or a code system. Terminology, external identifiers, and versions are opaque to CQL. CQL has no idea what this URL means. It's just going to pass it to a terminology endpoint and ask for an evaluation. And it just understands what a code system is, and it understands what a value set is, and can make use of those in operations like terminology operators. So you'll see this in CQL. You can use string valued codes, but only for required bindings, only in the case that the system is not in question, right? The system is established by the binding and the element definition. And so it's okay to say o.status in final.amended, because status can't be from any other code system. But any other terminology valued element, if you see that, that's an anti-pattern. Should never, ever do that with any other terminology valued element. Does that make sense? I think that's super important because I see this a lot. Because this pattern is so much easier, right? It happens a lot, but it's so unsafe. You just can't do it. It would match any system, yeah. Which would be very, very, very bad. And then, so most recent smoking status, for example, the O.value value is in current smoker. This is a terminology valued element. It's a codable concept. And that current smoker is a value set that has codings with codes and systems. And so it matches based on that, the system and the code. And then use tilde instead of equal. When you're dealing with terminology equality, the tilde is an equivalent, right? And that means with terminology, we're only matching on the code and the system. We're going to ignore the display and the version. So use code equality only if you really mean it, because it really does mean that the code, the system, the version, and the display are all the same on both sides of that, and you almost never mean that when you're talking about terminology. Yeah. And a lot of really hard to track down bugs are that, right? They're that result. Oh, in my instance, the display was lowercase, and I've got it declared as uppercase in my content. And yeah, those are hard bugs to find. All right, data access. I'm gonna breeze through this. Basically, CQL doesn't care where you get the data, where it comes from. It's intentionally silent about that architecture. So this example, observation in tobacco smoking status, where o.status is in final and amended. This evaluation, in order to get a successful evaluation of this retrieve, it requires observations in the tobacco smoking status value set. But how that actually happens is up to the environment. The engine can access the database directly, like if it's actually running inside a process that has access to the database. It might access that data via a service, so it might turn that call into a FHIR request and go access that from a FHIR API. It might access data that was passed in as part of the request. So this is like the CDS hooks prefetch case, where we're passing the data in, and then the engine just accesses the data that's available. Most of the time, this is actually some combination of the three in real environments. What we did in the engine was just abstract. This is the Java engine. The JavaScript engine behaves very similarly. And the .NET one does too. The provider layer is this abstraction that just is able to give data to the engine in the format that it expects. And that data access layer has implementations that deal with where it comes from in the actual environment. And finally, about data access and context, this is just a way to visualize what's happening when you're retrieving. There's an unfiltered context that all models have, and is like you're looking at the entire database. So if you're in an unfiltered context and you ask for observations, you're going to get all of them. Most often, though, we're in context, and when we're running, say, decision support for patient 100, that means we're going to get these encounters, because those are the ones for the current patient. So it gives you this kind of window onto the database from the perspective of a particular patient. All right, so next up, queries. I'm going to go through this really quickly. A query is set up by establishing an alias. So you say a list valued thing, and then you give it a name, and then you can talk about that. And you can do where clauses, lets, you can do withs and withouts, and you can sort, and those are queries. Functions, you can also define functions. This is one of the key aspects of CQL beyond FHIR. In FHIR, you have to just say everything over and over again. Whereas in CQL, you get to actually define a function, and then you can name that expression. It's basically a named expression, and you can reuse that wherever you want. So in this case, we have most recent colonoscopy performed and colonoscopy performed within 10 years. That colonoscopy performed where p.perform.to interval, that .to interval is a fluent function. You see that used in FHIR a lot, but we can, in CQL, actually define fluent functions that let us extend that FHIR syntax. So I can say where the performed to interval ends 10 years or less on or before the as of. And that performed, in this case, is a timing, right? So it might be a date time, it might be a period, it might be a string, age, range. And if you're writing logic against each of those cases, that gets to be really extensive. Basically, to really handle all of those different cases, it looks like that. And I'm not really actually handling all those different cases because I actually blow up if you say, if you run this on a timing or a string, right? Because we're not going to try to pull out the timing out of a string. We're not going to do that here. But you can see it's quite, and if you had to do that everywhere that you accessed performed, it'd be a mess, right? So we define this to interval that is a choice, and this choice is, across all of the timing elements in FHIR. This is the superset of the types that are possible there. So this 2 interval can be used with any timing type across all the FHIR elements. And what it does is if it's a date time, it gives you an interval of just that date. If it's a period, it gives you an interval from that to that. If it's an age, it actually goes and figures out the patient's age and calculates the interval based on that, and so on. So that gives you then this nice p.perform.2 interval, and then you can use all the timing phrases in CQL against it. Okay. So that's a best practice in general, to use those fluent functions to roll up logic like that. That happens all over the place. And we'll dig into FHIR Common in the Let's Build session and see a whole bunch of those kinds of fluent functions that make writing this kind of logic a lot easier. So then, is recommendation applicable returns true? Then what? So in the case of CDS hooks, we actually want to build up a card. And so that card has things like the detail, the summary, the rationale, the indicator, is it a warning or a message? And not only do we want to be able to say this patient should get colorectal cancer screening, but we want to say why. We want to give some indication as to why. And so what we do here is actually roll up. It's kind of hard to read, but we're rolling up the most recent FOBT, the most recent FIT, the CT colonography, and so this is a coalesce, which is basically going to return the first thing that isn't null in this list. And so this basically goes through, if there's no evidence of appropriate screening, then that's going to be your rationale. So either the patient meets inclusion criteria for colorectal cancer screening, but has most recent FOBT issued on, it's somewhere further out, or no evidence of appropriate screening. Right, so it's going to roll down and basically use all those data elements to calculate a rationale that it can then display to the clinician, basically a smoking gun. This is why they didn't meet this criteria. And then that all comes back through the response, and the CDS hooks response then is displayed to the clinician. So that's the decision support round trip. All right. One of the things that we added in the using CQL with FHIR is that we've been in the measurement case for quite a while now, dealing with negation. Things that are reasons that you didn't do something. We've got 10 minutes. All right. Okay. Reasons that we didn't do something. Before we talk about that, though, because there are things that you have to say and reasons that you didn't do something that cover the extent of an activity. And so we've been working with FHIR-I and terminology to correctly capture the notion of an activity extent. If you look across FHIR, there are all these terminology valued elements, things like procedure code and medication request medication, things that let me say what this activity is about. Throughout the request and event patterns, basically there are, right now, you can specify a particular code, or you can specify a higher level code that includes all the concepts by subsumption, and that's pretty much what you have in the actual instance. It would be great if we could say, it's one of these codes, but I don't actually care which one it is, especially in the request case, where what I want is I want you to prescribe one of these medications, but I don't really care which one you choose, that's up to you. So now we can say that. Basically, anywhere that there's a codable concept in FHIR, we can use this code options extension. There are higher level ways to do this as well, by specifying a protocol or using a request orchestration. If you're interested in those, the CPG has patterns that talk about that, but that's not what this is about. All right, so looking at a specific code, this example is medication administration, antithrombotic therapy administered. We are talking about a medication administration where the medication is in this antithrombotic therapy value set. An instance that looks like this with specific code is just going to have a coding. It's going to say, I'm RX norm 1116635, and that's ticagrelor. That's a specific code medication administration. For the most part, that's the kind that you're going to see. There's also Wait, did I go too far? No, I skipped that one. Okay, code options lets you say, instead of a specific code, I'm saying this medication administration, I administered some medication in this value set, but it's not really important which one. I just administered some medication in this value set. And so the text of that is value set antithrombotic therapy for ischemic stroke. And this extension, code options, actually points to a value set. So I can actually access that in the CQL by saying antithrombotic therapy class administered. I can say administered.medication.code options. This is a Fluent function that actually digs into the extension and looks for the one that has that URL and returns the value canonical, right? And then I can say that that code options equals that antithrombotic therapy ID value set. So that's picking up the antithrombotic therapy value set and comparing it to the ID. So I can use that mechanism to actually talk about classes of things in terms of the value set. So it turns out to be a really important pattern in stating the kinds of negation that we need in quality measurement and decision support. So following informative guidance from HL7 on negation patterns, we have typically 3 different use cases. The first is just documentation that an event did not occur, like some procedure did not happen. Documentation that an activity should not occur, like something is prohibited, you're saying don't do this. And then documentation that some activity that was requested was actually rejected. You asked me to do something and I said, no, I'm not going to do that. So given these use cases, there are 2 common patterns for the representation of negation in FHIR. There's absence and there's negation rationale, which is one of the above use cases together with a reason. So just looking at presence and absence is just what you'd expect. Is it there or is it not there, right? We just use existence and not existence. And on the closed world assumption, we can say that. Negation rationale then actually says, I need you to tell me this administration, I'm looking for this. If it's not there, you need to tell me why. And so I'm looking for a medication administration with a status of not done and a status reason in that medical reason value set. And that's that same class not administered. I'm looking for a medication administration in this antithrombotic therapy value set. I don't need you to tell me which one of these things you didn't do, because I don't care. I just need you to tell me that you didn't do any of the things in this value set, right? And that's what that code options value set does. Does that make sense? That pattern is like literally 15 years in the making. So if we didn't get that right, please tell us now. All right. And the next pattern is prohibited activities. Medication request, antithrombotic therapy prohibited. Basically, the do not perform is true. If you look at all this request resources, they have this do not perform. And if you say do not perform is true, then if that do not perform element is present and it is true, then that shows up, right? That do not perform is true is a really important part of that pattern, because if you just say do not perform equals true, then if it's null, it's false, and that's not what you want. So that is true. Make sure that you're only talking about the case that do not perform is present and has a value true. Does that make sense? That's important. All right, and then status reason and medical reason. And then rejected requests, where you're stating the positive thing, I want you to do this thing, I need you to have a medication request with antithrombotic therapy, and you're saying, no, I'm not gonna do that because, and here's why. And that is done with a task focused on the medication request that you're rejecting. Quality measurement.
3 minutes.
3 minutes. With questions?
Including questions.
Including questions, all right.
Well, you have Let's Build still, of course.
All right, so then the quality measure basically does the same thing. It takes the colorectal cancer elements and then expresses it from the perspective of a quality measure, where we're taking an initial population, a denominator, and a numerator, and just referencing those elements to reuse that. So now we've shared logic across the entire spectrum. just looking at the quality improvement ecosystem, these are all areas where we are actively working to make sure that we can say these same types of things in the same, using the same framework. So using CQL and using FHIR clinical reasoning, we can talk about computable representations of practice guidelines, delivery of those as CDS hooks recommendations, quality measures to specify how we determine what happened, DEQM to report what happened, ECR to do public health reporting and registry reporting, and EBM on FHIR to represent the research and payer health and surveillance side of things. In particular, we're using this in WHO guidelines. You may have caught Carl's talk this morning. We use this with the CDC opioid guideline. We have production implementations of this working with EPIC and CDS hooks. They use a clinical reasoning engine in the walkthrough that we just did. Quality measurement and reporting, we're using this in FHIR-based ECQMs. And public health reporting, we use this in e-case reporting in the ECR-IG. Learn more and get involved. There's a VS Code plugin users guide. This is what we're going to dig into in the Let's Build session. There are Cooking with CQL monthly sessions. We do this every month. And then Zulip CQL stream, ask questions there. And the CQL vNext project, if you're interested in that, come join us in the CDS work group and talk.
Does it include the new model info stuff?
Yes, yes, it does. And you can, let me go back. Sorry, they're in the slides.
Yeah.
All right, and then you can find, you can reach me here, GitHub, Zulip, LinkedIn, and email. And then join me in the Let's Build, where we'll get hands-on with these examples. And here's the learning objectives. Did we make it? All right.
One question.
One question.
Just for fun.
Just for fun. Any questions? All right, great. No questions.
Okay. Well,
Unless you have a question.
If we work with CQL and we think something's weird, what do we do?
So first thing is to ask the question on Zulip, or come to a CDS work group and say, I think this is weird. What should I do about it? There's also CRMI CPG project where we do a lot of, like the using CQL is a product of that sub-project. But also submit a JIRA.
Right.
There are also forums like Cooking with CQL. You can submit examples. Please submit examples because I need content every month to go through that. So if you have questions, submit examples there, and I work through them in real time.
And more or less, how often is a new version of the CQL spec released?
We haven't released a new one since 2020, so we're going on 5 years now. We've done errata since then. This is errata 2. The errata are feedback that we've gathered from all those processes, so Zulip and JIRA, and more recently the DQIC has driven a lot of stuff, the Digital Quality Implementers community. If you are building an engine and you want to make sure it runs all of the stuff, DQIC is a great place to go. But we are planning in September to ballot vNext, and that will include, but probably another year before anything gets published from that, yeah.
And I remember last year in Minneapolis, you had some really scary new additions to the language. Are these in vNext?
Yes. Yes, they are. The scariest one is the lambdas, and we're not sure that's going to make it in.
Right.
But that's, not sure that's going to make it in. Mostly because we don't know how to translate that to SQL.
No, I guess. So we translate it to CQL and FHIR view.
Right.
That's for smarter guys than us. Okay, thanks, Bryn. And see you, I guess, at the Let's Build. When is the Let's Build?
It's after the break.
After the break.
So
okay.
15 minutes to get coffee, and it should be in this same room. As far as I know, we're back here. So, all right.
Thanks.
Awesome. And if you want to get ready for that, the VS Code, just make sure you have VS Code installed locally with the CQ framework plugin installed. Does everybody know how to do that? Raise your hand if you don't know how to do that. Because I'm happy to walk folks through that prior if needed. Otherwise, enjoy some coffee. All right, thank you. Thanks. Thank you so much.